Throughout its history, the Marine Corps has been the catalyst and advocate for change. Today, the rate of change is accelerating at a dramatic pace, and once again, the Marine Corps is on the cutting edge. We are developing operational concepts and doctrine that will radically alter the battlefields of the future. In order to keep pace with these new tactics and strategies, today's warfighters must have exceptionally efficient and adaptable logistical support. We must use every resource to the fullest, build maximum flexibility into the system, and maintain the ability to adjust our plans quickly in response to rapidly changing threats. Total life cycle systems management must intertwine with logistics chain management. Operations and logistics must work, plan, and fight side by side. Support to the warfighter must be timely, accurate, and when possible, autonomic. Sense and Respond Logistics is the Marine Corps answer to this challenge. With applications and benefits across the enterprise, Sense and Respond makes usable information available to all stakeholders, ensuring the best possible decisions. Modern supply chain management techniques speed repairs and reduce downtime. In the Sense and Respond environment, the warfighter's needs are sensed and responded to in real time. In order to accomplish this, the efforts of a multitude of programs, policies, and initiatives must be coordinated and integrated, each leveraging the progress of the others. The Sense and Respond support system does this by integrating the many LogMod efforts, putting the pieces together in one coherent universe that benefits all stakeholders. Programs and processes such as these are each dependent upon the others to be truly effective. When the pieces are assembled, the value of the whole makes Sense and Respond Logistics a combat multiplier in the sea-based environment, while facilitating effective enterprise lifecycle management. The key piece of this puzzle is platform-level data, collected, displayed, analyzed, and translated into actionable knowledge. Following predetermined procedures, the knowledge is parceled out in a manner and format appropriate to the differing needs of each stakeholder. The information is processed and analyzed to determine what it means, what needs to be done, and how it will affect future decisions at all levels. The information will also generate demand for parts, technical support, and resupply. By integrating the many separate and diverse efforts directed at modernizing the logistics chain, we are able to sense mission-critical information and respond effectively at all levels: tactical, operational, and strategic. In this presentation, we will illustrate the process used to obtain a bit of platform-level data, show how it is sensed, and reveal the various responses it generates at each level. Our first step is conduct of a reliability-centered maintenance analysis. This is a method recognized and standardized by the Society of Automotive Engineers that enables us to fully understand the asset in question and develop effective maintenance procedures to preserve the desired function of that asset. RCM enables condition-based maintenance, in which system or component health is monitored so that maintenance can be conducted when required, rather than on an arbitrary schedule. Careful analysis will guide us to the appropriate condition monitoring technique and help avoid the pitfall of inserting expensive technology that sounds good but adds little value. Condition monitoring can also enable detection of a potential failure in time to correct or prevent it. Often, a predictive relationship can be discovered between the first indication of degraded condition and time remaining until component failure actually occurs. This is a Marine Corps light armored vehicle. It has been equipped with an embedded platform logistics system consisting of sensors, data bus, onboard computer, and a means to transmit the data from the vehicle to the operator, maintainer, and the enterprise. The operator receives basic information through a display aboard the vehicle. The maintainer has a portable maintenance device called an electronic maintenance support system with multiple functions, including diagnostic tools, interactive electronic technical manual, and a maintenance management program. This is the maintainer's gateway to needed information and is the enterprise window into vehicle condition and configuration, enabling smart operational planning and meaningful life cycle system management. On this vehicle, one of the embedded wheel hub sensors indicates a reading that is outside the acceptable parameters. Analysis of historical data has developed a basic prognostic indicator marking a high degree of probability that under this condition the planetary gear will fail in 12 hours of continued use if no corrective action is taken. This information is reported to the operator as well as to the commander and ultimately the enterprise through a local maintenance server that may be aboard the LAV command and control vehicle or in the maintenance facility. At the tactical level, through a common operating picture, field commanders can see that this vehicle must be taken out of the fight and repaired. Decision support tools and readiness modeling tools help the commander to understand how the loss of this vehicle will impact the unit's ability to carry out its mission. A service request is generated to GCSS Marine Corps. If the request meets previously defined criteria, a work package consisting of a qualified maintainer, parts package, and tools can be dispatched. Otherwise, a supervisor can intervene, taking action based upon the current situation to initiate the repair. The maintainer, using his EMSS tool to read asset health as reported by the embedded platform logistics system, is able to diagnose the cause of the fault and repair it with the help of the interactive electronic technical manual. The item is specific to the exact vehicle by serial number, reflecting all modifications made to that vehicle. The maintenance management application on the EMSS device guides the troubleshooting process and leads the maintainer to the appropriate section of the item, where the maintainer can also order needed parts by selecting them on screen. At the operational level, the demand is generated through GCSS to the supply system for the required parts. Using logistics planning and execution tools in the Common Logistics Command and Control System, it is possible to project resource requirements and plan realistic schedules in order to support the assigned mission. Commanders and logisticians can view the real-time operational availability of their units and status of supplies, enabling them to more effectively allocate resources to achieve a desired readiness level. Because major components and parts can be identified through item-unique identification, configuration management and asset tracking are accomplished easily and accurately. In addition, trend analysis and root cause analysis yield more meaningful results, providing accurate data to modeling and simulation tools that guide operational decisions and process improvements. At the strategic level, the status of fleet availability based upon the automatically reported asset health is reported to the enterprise. Inventory levels are also updated, reflecting parts consumption and availability. Decision support and readiness modeling tools collate and analyze the data, balancing fleet condition and operational tempo with known operational commitments to paint an accurate picture of current and future requirements and capabilities. The effects that sustained operations will have upon equipment life cycles can be identified. It is possible to accurately calculate the cost to bring vehicles to the desired state of readiness, as well as the cost to delay such investment. This is not a best guess based upon what has happened in the past, but rather an objective analysis of the current state of equipment, known probabilities of failure, and mission requirements. Data is summarized and reported to the Life Cycle System Manager for total asset visibility and trend analysis. Supportability and sustainment decisions are based upon the most reliable data, making accurate, readiness-based sparing possible. Necessary engineering modifications are identified early. Modeling and simulation can help define what percentage of fleet readiness is actually necessary to support commitments. Materiel availability goals are based upon meaningful data rather than an arbitrary number. During this presentation, we have shown the compelling benefits of integrating capabilities across the enterprise, from the platform throughout the value chain to the highest headquarters, making actionable information available to those who need it in a manner consistent with their needs enables operations and logistics to work together seamlessly to assure the best possible support to the warfighter. The need is clear. The technology exists today. Using Sense and Respond Logistics, we will achieve the logistics modernization necessary to support the groundbreaking doctrinal and operational changes coming in our Corps.